We're continuing with 13.1, and this was the section called Sinking Funds. You would like to buy a house someday and estimate you will need a $20,000 down payment to get a good rate on a mortgage loan. And so the down payment's what you're trying to accumulate, and that is going to be your future value. Future value is always positive. So $20,000 for future value. You currently have $4,870 saved and can deposit $375 every 3 months. And so for this particular one, we're saving money, and it's on a quarterly basis. The $375 every 3 months is your payment. We don't do anything with that except just keep it the same, $375. Because it's compounded quarterly every 3 months, that means quarterly. And our initial deposit, the amount that we have saved, is $4,870. Alright, and then if you found a money market account which pays 5.875% compounded quarterly, how long will it take to save up for your down payment? And so it tells us right here it's compounded quarterly, but it also told us basically here that it was going to be compounded quarterly by saying every 3 months. Okay, so we are actually looking for N. We don't know what that is, the number of periods. Our interest rate is 5.875. We are dividing that by 12. Remember, you push equals before you enter that on your calculator. This is what we're computing, right? How long will it take to save this down payment? Okay, so we are going to compute N, and once you have computed N, then you will have the number of periods. Remember, that's what you actually compute. So in this case, the number of periods is 27.70. So that is 27.70 periods. I'm just going to write that out. If we want to know how long that is, and we would like to know that in years, then we would divide 27.70 by 4, and that would be 6.93 years. So almost 7 years is how long it would take. Alright, next. You want to accumulate one, these are practice, so these are going to be similar to questions that we did earlier. So just remember to pause and try this for yourself, and then you can check it with me once you start the video again. You want to accumulate $15,500 to take a sailing trip to Tortuga, I don't even know what that is, in 7 years. You have found a money market account which earns 5.4375% compounded quarterly. What amount must you deposit today? So this is based on a one-time deposit so that you can take this trip. Alright, so 7 years, and it's compounded quarterly, right? So we are going to figure out all of this based on that. 7 years compounded quarterly means times 4 for the number of periods, so that's 28 periods basically. It's 5.4375 divided by 4 equals, don't forget the equals before you enter. We have a 0 payment. We're only just going to make a one-time deposit. We are trying to accumulate $15,500 at the end of the 7 years. Alright, so we are going to compute present value. Right, that's what we compute. And when you do compute this, it will be $10,000, $10,620.42. Remember, it's a negative because that's money that we're putting in the bank, so therefore we don't have it in hand, and we enter that on our calculator as a negative. Okay, you're still taking this sailing trip, and you're going to set aside some money. Your best friend wants to go with you, right? So it's going to be the same amount, but you need to set money aside on a monthly basis. If their savings account is paying 4.16% compounded monthly, how much will they need to deposit each month? So this one is based solely on payments, and that means our present value will be 0. Okay, so 7 years again. This one is going to be 7 times 12 because remember it's compounded monthly. 4.16% divided by 12. We are going to compute the payment. So we know the future value is $15,500 again. Here's what we compute. So this is what we will circle this answer. Okay, so when you compute this, right, you fill in all your keys in IYPV and future value, compute, hit payment, and then you should have this amount, $159.28. And so that's just strictly on a monthly basis that you're going to make this deposit or make this payment. Okay, on the next one. Your child's godfather Sam has generously decided to start a college fund for your daughter Anne. Sam estimates that in 18 years Anne will need about $60,000 to be able to go to the college of her choice. Sam can deposit stock dividend earnings of $750 twice a year into a trust fund account which pays 4.25% annually, compounded semi-annually, sorry. How much will Sam need to deposit today in order to make sure Anne can go to the college of her choice? Now that's a lot of information, and you can always go back and highlight what you need to find everything, but we don't have any extra stuff thrown in to distract us here. So 18 years later, compounded semi-annually, so 18 times 2, right? Because semi-annually is twice per year. We want to make sure that we remember that part. And then our interest rate is 4.25%, and we will divide that by 2 because it is semi-annual compounding. Then Sam can make a deposit of $750 twice a year, so that's a payment of $750. Sam is trying to accumulate $60,000 to pay for college, right? So that would be Anne's college fund basically. We are computing the present value, how much money needs to be deposited today to make this happen. Okay. And when we compute this, we find it would be $9,406.30. So that's not too terrible considering we are trying to accumulate $60,000. Okay, so I'm going to go through the next 3 examples pretty quickly so as not to run out of time here on the video. Susie just turned 27 and can start saving the $175 per month. Okay, so that's going to be $175, and the interest rate's 8.5% compounded monthly. What age will she be when she accumulates $1 million? So that's got a lot of zeros, and we're trying to get to that $1 million. This is strictly on a payment basis, so there's no present value. It was 8.5% divided by 12 because we're compounding monthly, and we are computing in. Okay, so when you compute in, it's a pretty big number, 527.76. We're going to divide that by 12 to see how many years that would be, and it is 43.98 years. Now we're going to add that to 27 because we said what age will she be? Okay, I guess I should underline the B. So we add that to 27. I'm going to just round that a little bit, and she would be 71 years old when she had $1 million. That's just a payment of $175. Of course, it's for a long time. It's for 44 years basically, but still, that's a pretty nice accumulated amount. Okay, on this one you want to accumulate $300,000 in 20 years. So that is our future value. Remember to pause this if you want to work this out on your own. And so we're going to do this in 20 years. You then plan to deposit $100 per month until you retire. In 40 years, you can earn 6.75% compounded monthly. You plan to deposit your bonus check this year of $2,000 to get your plan underway. What amount must you deposit each month to have $300,000 in 20 years? Now, we are going to combine this with the next question. So the next slide actually goes with this question. Okay, so first of all, we're just working on this 20 years. So that's times 12 because it's compounded monthly. The interest rate is 6.75%, and that is divided by 12 because of compounding monthly. We can put in the bonus check of $2,000 to get this thing started. And then we're going to compute how much we have to pay every month on this particular loan or this particular savings account so that we can get to $300,000. I think this is kind of an interesting question. So we are going to deposit $578.38 per month for the first 20 years, and then we're just going to let this thing sit basically and only put in $100 a month. Now what that means is for the next 20 more years, right? So 20 years, it says at the end of 40 years how much will be in there. So 20 more years, that means we don't change N, we don't change I, but our present value now is our $300,000 that we have accumulated in the first 20 years. We're paying a payment of only $100 a month. Notice that went down a lot because we were paying $578.38 per month. And then what will our future value be at the end of the second 20 years? And that's what we're going to compute, is future value. Okay. And so at the end of the second 20 years, which is really 40 years altogether, we will have $1,203,398.25. So I think that's a pretty good plan. You know, you're making more money for those 20 years and you get it to this amount, and then just $100 per month. All right, well, that ends 13.1 Sinking Funds.